Today's lesson is on evaluating algebraic expressions and learning the terms associated with algebraic expressions. Algebraic expressions are written with terms. Terms are separated by positive or minus signs. 8x plus 3y minus 2x squared plus 15 is an expression, and this expression is made up of 4 different terms. The terms in this expression are 8x, 3y, negative 2x squared, and 15. They are each separated by a sign. A negative term must be denoted with a negative sign. Terms may be single numbers, called constants, like negative 4, 5, 0.6, and 3/7. These are all constants because their value stays constant. Another type of term could be a variable. Variables are always letters that are used to represent unknown values. A variable could be x or y, a, b, any possible letter. Another type of term is the product of a number and a variable. The number in this term is called a coefficient. For example, in negative 4x, the negative 4 is the coefficient. In 5x, 5 is a coefficient. In 1/5 x, 1/5 is the coefficient. So terms can be made up of constants, variables, and coefficients. Let's look at the 5 terms in this expression. The numbers by themselves are called constants. The number includes a sign. So in this case, we have 2 constants in this expression. Negative 3 and positive 15, or 15, are constants because their value stays the same no matter what the variable values are. Variables are letters such as x and y. They represent an unknown value. So in this equation, or this expression, we see an x and a y, or an x squared. Those are all examples of variables. A coefficient is a number next to a variable. A number that is in front of a variable is called a coefficient. The number in front of the variable is either positive or negative. In this example, 8 and negative 2 are clearly coefficients. As you see, 8 is in front of x, and negative 2 is in front of x squared. There's also an invisible coefficient in this problem. 1 is a coefficient for the variable y. If we see a plus y represents 1. A variable by itself has an invisible coefficient of positive or negative 1. In the example above, positive y is equal to positive 1y. If we were to have negative x, that is equal to negative 1x. Algebraic expressions such as x plus y cannot be evaluated unless the variables are given a value. If the variables are assigned a value, we can substitute and solve. So if we evaluate this expression x plus y, if x equals negative 5 and y equals negative 3, we get negative 5 plus negative 3, and that is equal to negative 8. So once we substitute, we can solve. If we evaluate 3x plus y when x equals 2 and y equals 9, we can substitute and solve. 3 times x plus y is 3 times 2 plus 9. We substitute 2 for x and 9 for y. Solve for 3 times 2 and we get 6 plus 9. The answer is 15. Negative 7a. When a number is next to a variable, the coefficient next to the variable is solved with multiplication. This is the same as saying negative 7 times a. So if we evaluate the expression for negative 7a, when a equals negative 3, we're going to substitute and solve. Negative 7 times negative 3. A negative times a negative is a positive, and 7 times 3 is 21. So when you see a number next to a variable, we multiply. If we evaluate 3xy, that's 3 times x times y. So we're going to substitute and solve. 3 times x times y means 3 times 2 times negative 6. So if we start with 3 times 2, we get 6 times negative 6, and this equals negative 36. If we evaluate a negative xy, when we substitute and solve, we see that a negative xy could also be written as a negative 1 times xy, since this is an invisible coefficient. So now we substitute. We have negative 1 times negative 5 times negative 11. Notice we have an odd number of negatives. Our answer is going to be negative, and 5 times 11 is 55. We can also evaluate fractions. Remember, fractions are division problems. So if we substitute and solve, f equals 36, and d is negative 9. So 36 divided by negative 9 is negative 4, because a positive divided by a negative is a negative, and 36 divided by 9 is 4. In this example, f over 2g. First we substitute and solve. For f, we get 36 on the top. On the bottom is 2 times negative 6. So if we solve our denominator, we get 36 divided by negative 12, and that equals negative 3. Our last example for evaluating exponents evaluating expressions has an exponent. If we substitute and solve, we see that we have 4x squared, which is equivalent to 4 times 5 squared. Since 5 squared is 5 times 5, or 25, this is equal to 4 times 25. 4 times 25 is 100. And that's it for a review or quick examples of evaluating expressions.